So again, welcome back. Resuming from the part where we had left off in the previous video, we were on the verge of discussing something soluble to something soluble. So in this previous class, we have had some general idea about what pharmacokinetic stands for and what pharmacodynamic means. We have known some concepts about unscored and scoring tablets and some advantages of the scoring tablets. Then the basic idea of the generic names, brand names and chemical names, followed by a schematic diagram showing absorption and distribution and some part of pharmacodynamics. And we had left with this thing, something soluble to something soluble. Now, let's take an example. We utilize sodium chloride. Every day as common salt. Now, supposingly, your sister or mother or father ran out of common salt and he asks you to purchase this common salt. Now we also know that common salt can be derived using sodium ion and chloride ions. Now, follow with me. Why do we require sodium chloride and why not sodium ion and chloride ion in the kitchen? For this, we have to go back to the basics of biochemistry and physiology. In first year of MBBS, we learned something about fluid mosaic model postulated by Singer and Nicholson. In that, they gave the concept of a lipid bilayer enclosing its cell and its organelles inside our human body. So naturally, anything that has lipid-like property can easily get into the cell, whereas drugs that are water soluble or hydrophilic. Lipid soluble means lipophilic. So now coming to hydrophilic, they cannot easily pass. Obviously because the cell is being lined by a lipid bilayer. So can they ever get into or inside the cell? The answer is yes, with the help of aquaporins. Aquaporins were the channels, small channels, provided the water-soluble substances are also small in size. So, according to their postulation and according to what actually happens, lipid-soluble substances can get easily inside a cell. So with this understanding, let's go back to the example of formation of sodium chloride. I'll write here again, sodium ion plus chloride ion forming sodium chloride. Now, if my mother or my sister or my father told me to purchase sodium chloride, I will not act as a scientist. I'll just purchase this common salt from the grocery store. The brand could be Tata or Annapurna or etc. etc. Now, I believe you will also purchase this sodium chloride directly from the grocery store for the purpose of eating your curry or lunch or dinner. Now, out of this sodium ion, chloride ion and sodium chloride, someone is lipid soluble and someone will be water soluble. Now remember this, sodium chloride does not have any charge, whereas sodium ion and chloride ion carries charge. So from this moment, please remember, neutral compounds are lipid soluble, whereas charged particles are water soluble. Now, if you still have some problems mugging up this concept, remember this example. Suppose this is a boy and he has been asked by his elder to change the light bulb. Now, naturally, what he will do is he will not stand over a surface which is in direct contact with water, because he does not want to get electrocuted. So, for a person getting electrocuted, he requires water. And electrocution simply means the movement of ions from whether a positive or negative charge to the ground. Our earth has zero potential. So, anything that carries charge can make you electrocuted. So similarly, anything that carries charge are water soluble. Just remember it this way. Another concept. Now with this we have learned what lipid soluble means and what water soluble means. Now again, by virtue of the pH of a drug, we classify them into acidic and basic. Now in physics, there was a concept of like charges repelling one another. But in pharmacology, please remember, like reabsorbs like. Now what is this like reabsorbs like? So any acidic drug, if it is inside an acidic environment, it will be readily absorbed or reabsorbed. Similarly, for a basic drug in a basic environment, absorb. So for an acidic drug to be readily absorbed, it requires an acidic environment. But in exams, a common question is always asked. Suppose there is an acidic drug, and for maximum absorption, what is the environment? Acidic environment or basic environment? Obviously, we'll choose acidic environment. But will the environment be the deciding factor of maximum absorption? The answer is no, because for absorption we require maximum surface area. So in the exam, if a question is asked as such, an acidic drug is maximum absorbed in the stomach, the answer is no. It's always in the intestines. Now with this, we have also learned the concept of acidic drug being absorbed or readily absorbed in acidic environment, or the phenomena of like reabsorbs like. Now in yesterday's class or the previous class, we had left with this big question mark. As such, after a drug, when it has completed its activity or its action or drug effect, how are they excreted from the body? Now, if a drug is lipid soluble, easy absorption. After binding to receptor or after performing the pharmacodynamic activity, it has to be removed from the body, excreted. Now, between this, there is a gap. This gap is concerned with converting lipid soluble into water soluble for easy excretion, and this is what we call as metabolism. Now, metabolism is also known as xenobiotics or biotransformation. Now, let's move into biotransformation. Biotransformation. The textbook definition or the textbook understanding means chemical alteration of a drug. Chemical alteration of a drug. Now, this biotransformation is conducted or is processed with the help of two phases. Phase 1 and phase 2. Now, this both phase 1 and phase 2 will help in conversion of a lipid soluble drug into water soluble to prepare it for excretion. So in phase 1, there is no new formation of compounds, or we call it non-synthetic. Whereas phase 2 is called as synthetic. Now, in phase 1, we have 5 processes: oxidation, reduction, hydrolysis, not hydrogenation, hydrolysis, cyclization, decyclization. Now, oxidation, obviously, addition of oxygen, addition of hydrogen, addition of water. Cyclization means converting a linear chain structure into a cyclic structure. Decyclization is the opposite. A cyclic into a linear structure. Now, for the synthetic or the phase 2 part, we add a functional group into the lipid soluble drug. This functional group could be any, like it could give rise to acetylation product or acetylated product or methylated product, which we call as methylation, then glucuronide conjugation, etc., and so forth. So, both these phase 1 and phase 2 will ultimately render the lipid soluble into water soluble. Now, this step has made that particular drug ready for excretion. Again, excretion, it could be hepatic or renal, but renal excretion is more commonly asked as a part of long question. Now, this excretion would be dealt in a separate class, but This biotransformation or xenobiotics or metabolism has also some other functions. Not only conversion of lipid to water soluble, it could help in activation of a prodrug. Then inactivation of an active drug, the one that we had just discussed now, or it could help in formation of an active metabolite from an active drug, or formation of an inactive metabolite from an active drug again. So biotransformation again, this is repeatedly asked as a long question. Please note that the videos that I would be preparing in this channel would be meant to clarify the concepts. I will not go into details like this is the long question and you should write about this, and also everything has to be in a concise manner. You have to prepare your own notes, obviously. I'm just dictating the terms of how I understood pharmacology when I was doing my UG. So with this we have completed metabolism, but there are certain aspects of some concepts that we have discussed initially, like the absorption. Let's go back to absorption. So factors affecting absorption. The first and the foremost thing is solubility. Now we know that lipid soluble is more easily absorbed or reabsorbed. Then particle size. The smaller, the better. Then stability or ionization. Ionization simply means non-ionized means uncharged form. Uncharged means lipid soluble, easily absorbed. Then the dosing pattern or the dosing formulation used, like liquid is more faster absorbed than tablet and all. So some of the factors that affect absorption are more important than the others, but this itself you have to prepare a short note. And again, we should understand the factors affecting distribution. Here, the organs with a better blood flow or a high blood flow will receive more drug initially. Then we have another topic or a concept called as plasma protein binding, which itself will be discussed in a separate video later on. Then the pH of tissues, then capillary permeability, everything. If I get the chance, I'll attach the download links of the notes if possible at the description of the videos, So with this, we have completed till metabolism of pharmacokinetics. In case if you have doubts or suggestions, please do add in the comments. Now, happy reading. Thank you.